Hello, I am Professor N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology, and in this video we will solve this problem based on superposition theorem. Now, here as per the statement of the superposition theorem, current flowing through the load resistance is always algebraic summation of the currents when each source considered acting alone in the circuit. Here in this case we have the two sources. One is the voltage source which is of the 100 volt, other is the current source which is of the 8 amperes. Now we will consider the first case. In the first case we will consider the 100 volt source. By that time 8 ampere current source will be replaced by its internal resistance, and we will use the reduction technique. Okay, maybe in the next video I will discuss about the other techniques to solve the sums based on the superposition principle. Now here in this case we are considering this battery. Here the resistance will remain the same. This resistance also will remain the same. Here will be the resistance, and the current source has an internal resistance of infinite. That's why its terminals are kept open in the air, because air has an infinite resistance. That is 10 ohm, this will be the 10, this will be the 5, and it will be the 100, that is plus and minus. Its figure will be something like this. Now the two resistances are in series. Its next figure will be something like this. Here it is 5 ohm, and 10 ohm is in series with the 10, which is nothing but its resistance is 20 ohm. This is 5 ohm, and it is of the 100 volt. Now here we will find out its parallel combination. That is 20 ohm resistance is parallel with 5 ohm. That is 20 into 5 divided by 20 plus 5, which is 25. Divided by, it is 25. Its resistance is 4. Its resistance is 4. This parallel combination means here its next figure will be something like this. Here its parallel combination is 4 ohm. We have already calculated. It is 4 ohm. Here its voltage is 100 volt with plus and minus polarities. Now here we know the total current. We know the total current. In this particular case, we know the total current. That is current from the battery for case 1, which is I1. Now here, in this case, the total current I1 here, which is equal to total voltage divided by total resistance, which is 4. 100 divided by 4, that is 25 amperes is the current. Now here we know the current in this branch, which is I1, current from the battery. We are interested to calculate current in this branch because we are targeting this resistance or this branch to be exact. Here I will call it as IL1 for the first case. It is IL1 because the current whatever we have in the 10 ohm resistance, same current will be here, and its series combination will be the 20. Is this current is very same as this particular current. We know the current here, which is I1. This current is the I1. Now here in this case, if we are planning to calculate the current IL1, which is equal to this current, total current, this current, total current, which is 25, into resistance upon the opposite branch. In this branch current is known. We want to calculate current in this branch, that is remaining branch is the opposite, which is 5, divided by resistance of both branches. That is resistance of both branches, that is 20 plus 5, which is 25. Means here, as per this calculation, the IL1 is found to be 5 amperes, and its direction is forward. In this 10 ohm resistance, it is forward. I will treat it as forward. This is the current for the case 1. Same procedure we will follow for the case 2 and we will calculate its current in the similar way. That is nothing but similar methodology we will use here. Same thing. Now the case 2. In the second case, this is the case 2. In the second case, we will consider the second source, which is 8 amperes, and we will remove the first source by its internal resistance. This figure will be something like this. This figure is like this. 8 amperes. 10 ohm. This is 10 ohm. This is 5 ohm. And here is the voltage source. This voltage source will be replaced by its internal resistance. And the internal resistance of the voltage source is 0. That is short circuit. Means it will be replaced by the short circuit. Now, this short circuit is parallel to the 5. That is 0 into 5 divided by 0 plus 5 means this value is 0. This next figure will be something like this. This is the next figure. It is the next figure. This is 8 amperes. Here is 10 ohm. And this parallel combination will be 0. 0 ohm. This is 0. Here it is 10 ohm. And we are interested to calculate current in this 10 ohm resistor. This is load resistance for this example. Now here, this current is coming something like this, and it is going something like this for the 10 ohm, and it is something like this. Here, again, no need to reduce this network further, because why we are reducing the further circuit to calculate its total current? Already its total current is known. Now I will calculate IL2 directly. This will be the IL2, current in the load resistance for second case. This IL2 is equal to total current, which is 8 amperes, into current in this branch is known, which is 8 amperes. We want to calculate current in this branch, which is 10. And opposite branch will be the 10 divided by resistance of both branches, that is 10 plus 10, which is 20. Means here, in this particular case, its current will be the 4 amperes. Now look at the direction of the current in the 10 ohm resistance, in this resistance. It is a forward. Now here, if I am comparing both cases, in the first case, the load current is forward. In the second case, the load current is forward. That's why, as per the statement of the superposition principle, this current IL is equal to the first current, which is IL1 plus second current IL2, which is nothing but it is 5 amperes plus 4 amperes, which is equal to 9 amperes. This is the value of the current flowing through the load resistance as per the superposition.